Welcome, everyone. You're listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulbrich, alongside Tessa Murray and Reuben Saltzman. As always, your three-legged stool coming to you from the Northland, talking all things houses, home inspections, anything else that's rattling around in our brain. On today's episode, we have asked for listener input and questions, and you have delivered, so thank you very much. And we've got a very nice pile of electrical questions that we've accumulated over the last several weeks. As such, we're going to have another electrical conversation, but because I'm light in the electrical field, and Tessa, you probably would say the same thing. Reuben, you're a well-read person on all things home inspections, but we brought in an electrical heavyweight to help us answer some of the questions that we received today. So I'm very honored and pleased to have Mike Twitty with us. Mike is a longtime professional in the industry who Reuben got to know through the AFCI professional group. And so, Mike, thank you for joining us. Why don't you go ahead and just kind of say hello to the audience and give us your abbreviated CV, and we'll go from there.
Okay, good morning. Thank you for having me. Pleasure being here, and I'm honored to be here. I've watched several of your podcasts in the past. Matter of fact, I watched one last night on the Challenger panels.
Oh, sweet. You can tell us everything we got wrong.
Well, I'm not going to do that. My background is electrical. I worked for Ford Motor Company for 30 years in a industrial. We were the largest glass manufacturing plant in the world at one time here in Nashville area. And I was an industrial electrician, went through my apprenticeship there, retired after 30 years at the age of 48, which was a blessing, and kept doing a little electrical work. I got my state license and was doing some work just on my own, and started getting calls from real estate agents about concerns over electrical on home inspections. So that's what got me into the home inspection field. Tennessee enacted licensing in 2006. I started in 2004. That kind of sent me into the home inspection field. Been doing that since. I've retired from that last year, at the end of last year, but I've been doing training, and that's basically what I do now, is to try to train just in the electrical field for home inspectors.
So every time you retire, you just start a new, different full-time career, it sounds like, Mike.
Yeah. I started with the electrical. I'll pick and choose and do small jobs. I've got a little job I'm going to do this afternoon. Yeah, I can't quit working.
Love it. So, part of the reason we're having you on is that you're one of the most knowledgeable people that I've ever come across. You're also a home inspector. Well, you're retired now, but you did it for a long time. So you are an expert in this, but you see things through a home inspector's eyes. And so often we'll get electrical experts on here, and they'll either talk just so basic. It's like, yeah. Go on. We got that. We know we're home inspectors, but we're not completely ignorant. Or it's the opposite.
Right.
And they're talking way over our head and talking about stuff, electrical theory, where it has nothing to do with what we do. But you are right in that sweet spot. So I'm excited to have you on here and ask you a bunch of these questions.
Reuben, before we get to the questions, why don't you tell everybody again where to send the questions to? Because this is fun. I mean, we've been working on content for a long time, but it's really fun to dive into other people's curiosities.
You can email us if you send the email to podcast@structuretech.com. We will get that email, podcast@structuretech.com. We love listener questions.
So without further ado, let's go.
All right. Let's get into it. So the first one here, this one has to do with surge protection devices. And Mike, this is really what prompted me to think of you. Was I know you've written an article for, now I can't remember the trade publication. You wrote an article on these specifically, and we have given this to many of our clients when they have specific questions about it. We say, read what Mike Twitty says. What publication was that?
It was in two. The first one was in the AFCI Reporter, the November 2018 edition. And then I've submitted it to the International Association of Electrical Inspectors, IAEI, and that's in the July-August 2020 edition of that. And I think you can still pull that one up online. Now, AFCI archives the older Reporter articles. It's the same article.
Yeah, we'll link it back to this conversation too.
Yes. We'll find that link. We'll put it in the show notes here. But this question started out saying, I want to know more about this. Do your home inspectors, now this is to Structure Tech here, do our home inspectors add information in our reports when a home doesn't have a type 1 or type 2 surge protector on the house? And I mean, I can just answer that right off the bat. No, we do not. It's not one of those things where if we inspect a home built before, I don't know, when that go in the code? It was 2020 when it went in the NEC, right, Mike?
Right, as a requirement at service. Yes.
Okay. Yeah. So if we're inspecting a house built before that age, we're not putting a note into the report saying, hey, consider having an electrician come out and put one of these things in. We don't do that. But a better question is, does Mike Twitty do that? Or did you do it when you were still inspecting houses?
I actually did. I had a blank statement in my reports that I recommended whole house surge protection. Reason being, I've installed a bunch of these over the years, and they really work. Nothing will protect against a direct lightning strike. They're not designed for that, but switching surges and various things, internal surges in the home. I did put that in my report as a recommendation, not as a requirement, just as a general upgrade recommendation. Today we have smart homes. Everything has a printed circuit board now. Refrigerators, ovens, everything. It's not just the hardwired like we did in the past. And what these things will do will protect these delicate circuit boards against these surges. Where an old hardwired oven, refrigerator, whatever, it's not as delicate as these circuit boards. HVAC equipment, control boards on them are very susceptible. So that's why I started putting it just as a recommendation in my report.
Can we have a little more background information on what these are, what they do? I know where you're going, Mike, with the delicate nature of a lot of this new equipment, but it doesn't seem like it's something that I see. It doesn't stand out to me. So what am I looking for? And when I find it, how do I know it works? And so on and so forth.
What people are more familiar with are what they call the point of use surge protection devices. We've used those on our computer equipment, televisions, and so on. That's the power strip type. And the point of use surge protection devices are called the type 3. And they're still recommended even if you put in the whole house surge protector, which is generally a type 2. It could be a type 1 or type 2, and we'll go over that a little bit. Type 1 surge protection devices generally go on the line side of the service. They're usually installed by the utility company. I don't know about in Minnesota, but around here you'll see some overhead service drops at the riser, and you'll see this little canister that's wired into the triplex. You guys see many of them up there? They used to call them lightning arresters. Yeah, really?
No.
Okay. In this article, I've got a picture of one if you pull up that article.
Okay.
The utility companies around here used to do that at all the installs, new construction. They don't do it anymore. Those type 1s are, like I say, generally on the line side of the service. They can be installed on the load side of the service too. Type 2 is installed on the load side. It generally goes in the main service panel and is wired to an individual dedicated breaker. They actually make some models that are combination circuit breakers and surge protector that fits in the slot where the circuit breaker goes. So if it can take up the space, it can have two, basically they come in 2 single pole 20 amp circuit breakers, and it has surge protection for the main panel. And what they do, when I was talking about the point of use, in addition to the point of use, these protect the things that don't, like the refrigerators, the stoves, the HVAC, that don't have that ability to plug into the power strip like the computers and the smaller appliances.
So it's on the individual circuit. Is it the main shutoff that this is built into?
The type 2s generally go in the service equipment, the main service panel. Okay. And the 2020 National Electric Code, when they started requiring these in new construction and upgrades, they said that they had to be in the service equipment or adjacent to. Now there's an exception to that, and I can read it if you'd like for me to. It says the SPD shall not be required to be located in the service equipment as required if located at each next level distribution equipment downstream toward the load. So if they don't put it in the service equipment or immediately adjacent to, they have to put it at each downstream subpanel, one
Makes
in
sense.
each one.
And Mike, how much do those devices cost roughly?
They vary. You can get them as cheap as $40, and you can pay $300 or $400 for them.
And these are type 2 you're talking about that go in the service panel. Yeah.
The type 1s generally, like I say, are installed by by the utility company. Sometimes you'll see them on specialized equipment. I've seen type 1s on a sub panel that is dedicated, or a disconnect that's dedicated to HVAC equipment. You can put either one on those. Now you can put a type 2 on ahead of the service equipment. The NEC allows that, but it has to be listed in a listed installation and have overcurrent protection. That's if a type 2 is on the line side, and that's very rare. You wouldn't see that. They're just going to put a type 1 on that side.
It just makes so much sense to install one of these devices. If it costs, anywhere from, even on the top end, like you said, $300 to $400, you're potentially saving yourself thousands of dollars worth of damage if you have, a surge in the electrical system that wipes out all your appliances or damages your wiring or something. And after reading your article, Mike, I was like convinced this seems like a really good recommendation to make for a lot of people.
I think it is, and they actually do work. Most that I installed over the years, I probably installed 30 or 40 of these, and generally with my labor, the cost of the device and so on, generally under $500. That's a pretty low cost for what it can protect.
Yeah, makes a lot of sense.
And I did a video. It's kind of a sped up video. I tried to make sure it was under 60 seconds, showing the entire process. It's not supposed to be a how-to, because I'm not talking through all the different safety things, but I went in my own house. I took the panel cover off. I moved some breakers around because the installation instructions said it's supposed to be installed at the top of the breakers. Moved some stuff around, popped one in there, put the cover back on. And the whole thing is kind of sped up, and it shows it in 60 seconds, just so people get an idea of the steps involved. Because a lot of people think you're opening up your panel, you're doing work in there. Oh, this is going to be a half a day. It's like, no, it's not that big of a deal.
Really simple, yeah.
Yep.
And
If you've got space for it.
If you got space, right. That can be a problem with them. You'll see them double tapped a lot because there won't be room for them, and they'll double tap them off of one of the other branch circuit breakers. Another thing that comes up is this Eaton type. They make like 3 different levels. They've got a micro, which is the cheaper, lesser protection, and then they've got what they call their ultra. Their ultra is to be attached to a 50 amp double pole circuit breaker dedicated. What comes up a lot, I get a lot of questions on these from home inspectors. The manufacturer puts a number 10 wire on this device, and it's attached to a 50 amp circuit breaker. So the question comes up, is this wire not undersized for this? It's a good question, but really it's not, because they have no load on them other than the LED lights. Device doesn't pull any load at all. It's designed to absorb energy when there is a surge or a spike. So the manufacturer kind of trumps code. If they say that number 10 is sufficient for this device on a 50 amp breaker, then it's compliant.
Is that something that's labeled on the visible side of the breaker? So when an inspector or anybody's digging around in there, they can look at it and not call out something that needs to be fixed that's truly not an issue?
No, it should be, but it's not. And that's why that question comes up a lot. Yeah.
Before we move on, sorry, Reuben, can you just go into what that absorption, what that means? Okay, so you've got this device, it just takes on the extra load and blows up, and instead of blowing the whole thing up, just blows that thing.
Right, and they can be sacrificial, not always, but if they take a big enough hit, they take that hit and absorb that energy to protect the equipment, your computers or your refrigerator or whatever. The component in these things that's the critical component is called a MOV, a metal oxide varistor. And that's what it is actually a variable resistor. It has a very high resistance when it has line voltage across it. When that voltage increases, like a spike, a surge, and that voltage elevates, then the resistance of this variable resistor, actually varistor, but it's a variable resistor, that resistance drops, and it takes that energy that would be going out to the device, to the equipment. So that's what the MOV does. It absorbs that energy. There are different SPDs have different modes of protection. The best ones have 4 modes. That's line-to-line protection across the 2 phases, the 2 legs. Line to neutral, that's 2. Line to ground, that's 3. And then neutral to ground. You can have a surge on any of those 4 situations. Yeah. Now, some of the type 1, most, not all, but most type 1s only have 3 wires. They have, because at the service equipment, we have a triplex, you got 2 hots and a neutral, and that is your grounded conductor at the service. So there's no equipment grounding conductor to connect to, so they only have 3.
I want to ask you real quick too, before we get off surge protectors, just one more question. And if you have, say, a type 2 SPD on your service equipment, should you bother installing surge protectors in individual locations? Like, should you still have one for your computer and your television and whatever else? Is it worthwhile, or are you really covered for your whole house?
You definitely should still have your point of use protection at your electronic devices, your computers, your television. Yes, it's not a redundant, it's added protection when you do that.
Okay.
So yeah, definitely recommend. And one other point I want to make, there's a lot of controversy and misinformation when a lot of home inspectors and other people will say, if in older houses, when they don't have the equipment grounding conductor and they have the point of use surge protector on their equipment, and a lot of people are telling people that there's no point in using it because it won't protect because it doesn't have an equipment ground. That's only partially true. That's not necessarily true, because you still have the line to neutral protection. A lot of surges don't even involve the equipment ground. You can have a line to neutral surge, and if you get that, then it still protects. It doesn't have the line to ground protection that would in a modern home, but it does have that line to neutral, which could still protect your device.
Can you give an example of what like a line to neutral surge would be caused by?
It can be several things. According to the data that I've read, the majority of surges in homes are internal surges. And that's like on a hot summer day, your air conditioner's running, maybe you've got your microwave going, your oven, you've got a lot of loads going on. Okay, when that couple of those big loads cut off, like the air conditioner cuts off, that voltage that's been pulled down tends to spike back up. That's an internal surge. Those are generally not as damaging as like a switching surge from the power company, lightning. I did a repair on one house where a car actually hit a power pole and the transformer exploded. And they didn't have surge protection on this very high-end multi-million-dollar home. It blew up their control board for their salt system pool, the hot tub, the sub-zero refrigerator was knocked out. 7 the high-end smart dimmer switches were killed. It knocked out the board on the heat pump.
What a pain in the butt.
The owners were actually out of town at this time, and it was pretty bad. So I ended up they had a 400 amp service, and I put in 2 whole house surge protectors on that after replacing all these dimmer switches and so on.
I mean, when I hear about surges, I think of lightning, but there's so many other potential reasons for it.
When they start doing some transformer switching at the substations, they can send a pretty substantial surge into the homes.
My guess is they have no liability for that either. It just is what it is.
Yeah, it's your responsibility to protect your own house. All right. Now, I said we were done with surge protectors, but just one more question. What if somebody's installing, like, say, an induction range? And this comes from the person who was asking the same question. So I got to cover their last question. You got like a 50 amp induction range. Is there any point of use surge protector you could install for something like that? Or do you got to just let your whole house SPD take care of it?
Right now, that's about the only thing you can do on something which is a 240 volt higher voltage appliance. They don't make like a point of use for anything other than 120 volt at this time.
Okay.
So the whole house, that's what it's basically designed to do, is to protect that.
So moving on, we're going to have to title this show Everything You Ever Wanted to Know, and then a lot more about surge protectors. No, this is good info. I love it, because we get into a lot of deep dives on here. But the next one was on AFCI devices, and this is partially from me, partially from other people who have written into me asking about these pesky arc fault circuit interrupters. And for anybody listening, it's usually comes in the form of a circuit breaker. It gets installed at the panel. They've been around for about the last 20 years or so. And the job of this thing is to prevent fires. But the incidental thing it does is it trips when you don't want it to, when you have electronic devices that aren't quite compatible with these. And usually it ends up being things like treadmills and vacuums, and usually things with motors, but it can be refrigerators too. And it trips, and it's super obnoxious. I had some in-laws who had these at their house, And after dealing with all of this nuisance tripping and having the electrician come out and this, that, and the other, they finally just said, to heck with this. And they took out the AFCI breakers and they installed traditional breakers. It's a code violation. I'm pretty sure you can't do that, but you can, and they did. So, Mike, I want to hear your 2 cents on all of this. What is the deal with AFCIs, and why, after 20 years, don't we have this dialed in and figured out?
Yeah, good question. And they're better. They are much better than they were. Kind of like, and you remember the GFCI had similar problems. The early GFCIs would nuisance trip, and they've really improved those quite a bit, where they can be used on various things that were tripping them earlier. Now, AFCI, as you mentioned, motors are the big thing. And what an AFCI is looking for is a deviation in the sine wave. It's looking at the sine wave. If you're looking at a AC sine wave, it's the up and down hills and valleys, I call them. And anytime there is an erratic signal or signature in that sine wave, that's what the AFCI is looking for. Now, motors will do that when they start. It's just part of the characteristic of an electric motor. And that's the big problem with these AFCIs. And they're still trying to hammer out those details, but you're right, they still nuisance trip. I'm not seeing as much of that. I don't know if you guys are, but as I did 5 years ago even. And with the dual function that we're seeing now because of kitchen requirements, people think all kitchen receptacles have to have GFCI protection. That's not true, but they do have to have AFCI protection. Now they're putting these dual function that have breakers in that are covering both the AFCI and GFCI requirements. And they seem to be a little bit better, in my opinion, what I've seen.
We had a condo that we owned with another family, and it was in a rental pool. It was built in 2007. The service panel was in a locked, separate room, and it had AFCI in the panel. And this thing would trip on, no doubt, Saturday night. And it was all the lights to the second floor. And it was the biggest pain in the arse, because it was how much money you spend on electricians or the manager to come out at 10:30 on Saturday night to go flip that switch, because of course it's in a locked room. I'm not there. I'm 180 miles away. It was such a pain in the butt.
Right. And I think some manufacturers are better than others. I think Square D had a lot of issues with theirs in the beginning. I don't know, probably Eaton seems to be one of the more stable ones that I'm seeing out in the field right now. So.
Interesting. And, I want to touch on something you said here. You mentioned how there's no requirement for all outlets in a kitchen to be GFCI protected, but most outlets need to be GFCI. As long as you bring that up, you want to just let our listeners know the ones that don't need GFCI protection in a kitchen?
Yeah, all kitchen counter receptacles have to have GFCI protection, and any receptacle that's within 6 feet of the outside rim basin of a sink has to have GFCI. So for an example, a refrigerator, a lot of people don't want them on a GFCI because of nuisance tripping in the old days. If the refrigerator is not within 6 feet of a sink, it does not require GFCI protection. Sometimes you'll see lower above baseboard receptacles in a kitchen. Same deal there, but they do have to have arc fault protection. I offer that question sometimes some of my classes, and everybody always misses it. I say all kitchen receptacles have to have A, GFCI protection, or B, arc fault. Everybody always says GFCI because that's the logic.
Sure. Yeah, makes sense. Okay. And now, what would you do if this is your own house and you've got this new refrigerator and you've got let's say a Square D panel, and your refrigerator keeps tripping once a week? It goes out. What would you do, Mike?
First thing I would do is try another breaker. I would try that first. I would replace that breaker with another one, because sometimes it can just be a faulty breaker.
All right.
In any event, if it continued, then I'm going to take it out and I'm going to put a standard breaker back in.
Because you can't live with that.
No.
Right?
Can't. Right.
Yeah. And okay, I'm glad you said that, Mike, because it's realistic. It's what anybody would do. And while it does make your house less safe, I mean, let's put it into perspective. I live in a house that was built in 2001 or 2002. I don't have a single arc fault breaker in my own house. Well, okay, I got one for a circuit that I added on to, and I said, I'm going to be code compliant here. But my house was not built with a single breaker. Does that make me feel unsafe? Do I lose sleep at night over this? Not at all. I'm perfectly fine with it. And I'm not going to go in and retrofit my whole house and put in AFCI devices. And so for someone to take a step back on one area where it's causing them a lot of headache, I don't know. I appreciate your approach, Mike.
I'm the biggest hypocrite in the world. My house was built in 1996. I tell all my clients, I recommend that arc faults are a good safety protection. I don't have a single one in my house.
Oh, you're the worst.
Shame on me, right?
You're the worst. No, I got it flip-flopped. I don't tell people to put in AFCI devices, but I do have the surge protection device. And well, I'm going to start telling people to do those. Mm-hmm. Now that we had this conversation, I think those are a great idea.
They are.
Yeah.
I agree.
Now, something else that we kind of segue into here, because you talked about GFCIs and nuisance tripping, and you also brought up how people don't like to have them on the refrigerator. And I just had somebody write in today about what about sump pumps plugged into GFCI devices. Talk about that for a minute, Mike.
Yeah, and that's a good point, because usually the sump pump, that receptacle is generally, that's all it's used for. That's what that sump pump's plugged into. Mm-hmm. And the GFCI protection is generally, if you're using hand tools or whatever on a concrete floor, a dirt floor or something, is to protect you from electric shock. So unless you're actually handling this sump pump while it's energized, it's really not a safety concern. That's the GFCI is for protecting people. It doesn't have anything to do with protecting that pump. Mm-hmm. So, but the code is always trying to protect people, which is good. And Uncle Harry is going to crawl under there, and the closest receptacle for him to use his drill to drill a hole through a joist to run a pipe or whatever is that sump pump receptacle. There was an exception for sump pumps at one time on the GFCI. Now anything, in the crawl space has to have it. So that's why just people do stupid things, and the code is trying to eliminate stupidity, and it doesn't always work. But
and just for clarification, you say crawl space. Here we don't have many crawl spaces, but we have unfinished basements, so same thing.
Yeah, same requirements. Yes.
And wasn't there a change in 2020 that said basements need GFCIs, whether they're finished or not? Or
yes.
Okay. All right.
Yeah, they added that. It used to just be unfinished basements. Yeah. Now it's basements. Yeah.
Okay. All right.
And back to the newer GFCI technology, the newer ones, you're not going to have that nuisance trip on that sump pump like you did in the past. They're a lot better as far as the nuisance tripping. The GFCIs are. Mm-hmm. So I don't really have a problem when I see them now. If it's on an old type, before, they call them the smart GFCIs when they change that technology. You could actually wire them backwards. They would work, and they won't now. So the newer ones are a lot better. If I saw one in a older home and it had the older type GFCI, I might recommend you might want to upgrade this to the newer technology, because they're a lot less apt to nuisance trip.
And just to date that, I mean, we're talking that change happened around 2003, right?
I think so. The smart GFCIs you're talking about.
Yeah. So this is they've been around for a long time. When you think about the life expectancy of a GFCI, chances are you've already replaced it because it went bad.
Probably so.
Well, and the problem with the old ones is they'd go bad in the on position, right?
Right, and they don't trip. Yeah, they're a regular receptacle anymore.
Yeah.
Take just 1 second and delve into that just a little bit, because that's interesting.
If you trip one and it's still energized, it is wired back. GFCIs have a line side and a load side. And the old ones, if you wired the incoming power to the load and the out off of the line, you could trip it, and that receptacle stayed energized. And you guys have probably seen that. You put your tester in, you trip it, and it's still hot. Generally, that's because it was wired backwards. And as Reuben pointed out, the smart ones came in around 2003 or whenever, where the technology, if they won't reset at all, they won't energize unless it's wired correctly. It's looking for that power coming into the line side. And they upgraded that, which was a great upgrade.
Yes. And correct me if I'm wrong, Mike, but wasn't that largely driven, this change that all the manufacturers made? It was a voluntary change. And it was made as the result of a survey that was sent out to ASHI members, the American Society of Home Inspectors. It was this big survey that home inspectors took a part in, and they discovered that there's tons and tons of breakers out there that are miswired or defective, and they're still energized, and they're not protecting anybody. And all the manufacturers got together and said, well, what do we do to fix this? Right?
I think that's, I remember reading that at some point, maybe Douglas Hanson told me about that, or he had written about that at one point, that ASHI did get involved in that. I think that was many years ago.
Yeah. Probably about 22, 23 years ago, something like that. But I remember seeing the survey when it came through.
Yeah.
All right, good stuff. We're taking a trip way back down memory lane. Good times. All right, Bill, Tessa, any questions about AFCIs, GFCIs before we move on to electric panels?
I don't think so. I guess my takeaway, just to recap, Mike, on the AFCIs is that, they used to trip a lot, nuisance tripping, but you said they've gotten a lot better in the last 5 years. So maybe we just need to hold out hope. And if you've got a house that was built in like the 2005, 2015 range, and you've got nuisance tripping, try to replace that breaker first, and hopefully that'll solve the problem.
And the problem hadn't gone away. I think Reuben was talking about probably seeing some fairly recent ones that are still having problems. But one thing to keep in mind, this is the thinking that people have always had with GFCIs and arc faults. Sometimes they're telling you that something's wrong.
Yes.
Don't ignore the red flags or the signals that they're giving you.
I've had people call me out and said, I want you to take this GFCI out. It keeps tripping on my freezer. And I did some testing and there was actually a ground fault on the freezer. I said, it's doing what it's supposed to do. You got a problem with your freezer, not with your GFCI. So that's something to keep in mind. And arc faults can be the same thing.
Sure.
Good point.
Excellent. All right. So last thing to cover, and this goes back to electric panels. We had a good discussion just amongst the three of us, me, Bill, and Tessa, recently, talking about different panels. And one of them was saying, Challenger panels. I've seen a lot of home inspectors get super whipped up and huffy about these panels, and they quote sites that quote sites that quote sites, and it's like bad press creating bad press. And for me personally, I've never seen anything that has convinced me that these are bad panels, but maybe you have. And I'd love to hear your thoughts on Challenger panels, Mike.
Actually, I watched your podcast last night on that subject. It was very good. I tend to agree with you, Reuben. I personally have not. I've seen a lot of Challenger panels. I've worked on a few. Don't see a lot of them. They weren't a real high volume panel in my area anyway. But I've personally never seen an issue with one. I've seen the same things you've seen, and typically you see a lot of pictures, and it seems like it's kind of a characteristic of the main breaker overheating on them. There was a version of an ITE panel. You guys are familiar with the ones that home inspectors love so much, where you got to take off the big heavy ring first, and then you got to take off the inside dead front. The old ITEs, and they had the early versions of them were pull-out fuses in that same cabinet arrangement, and then they went to a main circuit breaker. When they went to those with the main circuit breaker with the double panel covers, I call them, I've replaced 4 or 5 of those. They had a problem with those. The bus bars would oxidize heavily. Breakers would start arcing, and I moved breakers around on them until you run out of room, and then you have to change the panel out. That one never gets called out. Never see anybody talk about that ITE panel. ITE has a good reputation. That's the predecessor to Siemens. But the same with the Challenger. I personally have not seen a problem with the Challenger. And I agree with you. I haven't seen enough evidence to just blanket call these out as being a problem.
Sure. And what about there's another one out there that we hear brought up a lot. It's the Bulldog panels, also known as Pushmatic panels. And for anyone who's never seen it or you're not sure, it's this breaker where you actually push it in to reset it. What about those, Mike?
Those were actually great panels, in my opinion. The quality on those were very good. They were ahead of their time. One thing I liked about them is they had bolt-on breakers. The breakers actually bolt or screw into the bus bar. One problem with that is there's another screw next to the bus bar, and sometimes people would put the branch circuit conductor on the wrong screw. They wouldn't put it on the one that attached to the breaker, and they're just feeding directly off the line bus. And it's very easy to make that mistake. If you look
That'd
at
be bad.
Yeah,
Yeah.
if you look at one, look at the bus, and you'll see the adjacent screw, and sometimes they would just by mistake go on the wrong screw. But the Pushmatic back, they were a very well built panel for its day. Now, I think you discussed this in your other podcast too. The big problem with them is basically obsolete. As far you can still get replacement breakers for them though, by the way, but you can't get arc fault breakers, dual function breakers, that type. They're limited in what you can use them for.
Sure. Now, we talked a little bit on that podcast. We talked about availability, or no, we talked about service life.
Mhm.
And I've heard people throw out the 40-year number and saying after that, maybe it's past its expected service life. When you're doing home inspections, would you ever tell someone with a 50-year-old panel, hey, look, this is really old, you should probably replace it? Where do you come down on that, Mike?
What I would do a lot of times is the panel itself, as far as, unless it's had water damage or been exposed to something or corrosion or something, that bus and that cabinet is pretty solid. Now, changing out the breakers to newer breakers in that panel is a good idea. A circuit breaker, and I think you guys discussed this, nobody exercises their circuit breakers like they should. They can get jammed up when they get old. But if you had an old ITE, well, even an old Bulldog panel, if you could get the replacement breakers, then the newer breakers are, that's a great upgrade. The bus and the main panel board is generally, there's nothing going to go wrong with that. So unless it's it's got obvious signs of deterioration from age, then that's a different conversation. But
Okay.
it's just because of it's old. I mean, a copper bus is a copper bus, and it's as long as everything's tight and not deteriorated, I have no problem with it.
Okay.
I think one of the things that happens though when you get some of these older panels that look funny, the split bus panels, the Bulldog panels, is people just don't really intuitively understand them, which then creates uncertainty, which creates, well, do I really want this? And for you, Mike, you're like, hey, that's not a big deal. But for the average person, they might just not have a lot of confidence with it.
True. And I'm probably in the minority as far as an electrician. Most electricians are looking for work and, yep, that panel's 20 years old. You need a new one right now. And I can do it tomorrow.
Oh, man. Yes.
I'm kind of the, if it ain't broke, don't fix it type thinking. But, each one has to kind of be evaluated on an individual basis. You can't just say that all Challenger panels are bad or none of them are bad. It takes individual evaluations.
And I think to your point, it takes somebody who understands what they're looking at. All electricians understand what they're looking at. But then there's other levels of expertise where you're like, oh, I can quote unquote modify this to make it more modern by doing X, Y, and Z, where the next person might go, it's just move it to this and you'll be happier with that, right? Like, so we all have opinions and we all express them differently and try to solve the same situation probably 3-4 different ways. So it's always up for discussion when you get into these sorts of one-off types of panels that are left laying around.
Oh yeah, there's a big difference between repairs and upgrades. And some people want an upgrade, whether I've changed panels for people when the homeowner just decided it was old and they want a new panel. I said, okay, that's your call. So.
And then you take the old one that's just perfectly functional and you use it in a shed somewhere. And
I actually use them in some of my training. I've got some, I've taken out some stab lock panels. I carry them around, lug them around and show them to guys, because a lot of guys don't open them. And that's another discussion we could have, because they're stab locks and they like looking at them. I found an interesting, I don't know if I sent it to Reuben. I sent it to Douglas and Jim Caton. Something I found just playing with one that I had that had a double pole breaker, and you could, depending on where you plugged it into that panel, it either went across 2 poles or both poles went across one leg. It could make it a tandem, which was not designed for. You could plug it into 2 different slots, and depending on where you plugged it in is what it would be on 1 pole or 2 poles, which I never realized.
You did send that to me. Yes.
Yeah. And Douglas said he'd never seen that. He was amazed. He said, just another reason to crash and burn the FPEs.
Yeah. Yeah. Now, all right, we're just about out of time here, but I do want to hear your 2 cents on opening an FPE panel.
Yeah.
Okay, and that's a good discussion. And I totally agree with the majority of home inspectors I talk to say they don't. If they see an FPE, they just recommend replacement, which is fine. When I was doing home inspection, I would promote myself also as an electrician. So I'm going to open it up. Reason being is, you know how people procrastinate. You can recommend that they replace that panel. Whether they will or not, I would say it's not going to be happening in a timely manner. So if something's going on in there that can happen in any panel, loose connections, bad situations going on, double taps, whatever. Double taps aren't that huge, but anything that can cause heat and a fire, I feel like I have a responsibility to look at it, you know.
Sure.
So that's why I do it. But as far as I have no problem with an inspector saying that's an FPE, I'm not going to open it, replace it. But if there is a ongoing problem, I kind of want to know about it at the time of the inspection.
Okay.
Mike, have you ever had the breakers fall out on you?
On the Zinscos?
Zinsco or even FPE.
I haven't on the FPEs. They've got their plug-in is actually a little bit. I mean, it's not like the Zinsco. They've got what they call an E slot and an F slot, and it snaps in. So it's better than the Zinsco. Now the Zinsco, I've had them. If you have an open slot and you pull the panel off, and they slide down.
Yeah.
They just
Yes.
they just go down the bar. There's nothing to hold them. So
Yeah.
they're kind of interesting. But I haven't with the stab locks. I really haven't had any of those come out.
Oh, that's good. I have.
That's fun.
And I ended up doing electrical work, which I am not licensed to do, to put it back together and not leave breakers hanging out of the panel when I left the house.
Yeah, but the
Right.
statute of limitations have long since expired on when you did that electrical.
Exactly. And you have no idea what house this was. This was probably a decade or two ago. So that's why I'm talking about it today. But that's also why at my company, we don't open those panels. But
The FPE
I appreciate,
panel.
yeah.
For
No,
clarification.
nor Zinsco Sylvania.
Or Zinsco, yeah.
Yeah.
Yeah,
Well,
and I just tell people that when they don't, just make sure that the client knows that you didn't, and
Yeah.
they may want to have an electrician do an evaluation. I mean, if they're not going to change it out, at least have it looked at.
Mhm.
Yeah.
Yeah.
All I can picture right now in my head is the conversation. Mike, you're at the table. Douglas is at the table. I just want an all cam and on a Zoom meeting being recorded, and just to lob out some electrical questions and have you guys dissect all the crazy things you've seen over the years, and bring in the other heavyweights just for fun. I'm a kind of curious fly on the wall sort that way.
That would be
well,
fun. And
Yeah, we've had Doug on the show. You mentioned James Caden. We've never had him. We got to have him on the show too.
those two guys are walking libraries. They're amazing.
Yes.
And anyone that any home inspector that doesn't have Douglas's inspection of existing dwellings is missing out. That's the best publication anybody's ever put out.
Yeah. Hands down.
Money
Yep.
well spent. Money well
Yes.
spent.
Yep. Second that.
Well, Mike, thank you for spending an hour with us. It's amazing how fast we can burn through 50 minutes of conversation when you just start yakking about things. But we really appreciate you giving us some time today. It's invaluable for people who are listening, just the little tips. I mean, I learn something by accident every time we record a podcast. So thank you for your expertise. Thank you for your time. We appreciate it. This is being recorded just before the 4th, but will come out after. But for you and your family, I hope you have a great 4th of July weekend and you get a chance to relax, unwind, and take in a beverage of your choice. But we appreciate you coming on.
Thank you. Appreciate you having me. Appreciate you guys doing these podcasts. They're really good.
Yeah, and if anybody wants to look you up online, or is there a good place to track you down?
I've actually, since I stopped my inspection, I canceled my website. But you can, if you go to the articles, or I'm on AFCI's website, they can contact me that way through AFCI or through the references on the article.
Awesome.
Cool.
Thank you. That's going to be a wrap for today's episode. You've been listening to Structure Talk, a Structure Tech presentation. My name is Bill Ulrich, alongside Tessa Murray and Reuben Saltzman. Thanks for listening, and please keep the questions coming. Enjoy the holiday, everybody. I hope you had a safe one.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.